All right, guys. So, real quick recap from yesterday, whenever you did the kind of self-guided notes on the periodic table. When you look at the periodic table, excuse my drawing, um, you have kind of the periodic table split up into different sections. There are the group A elements, which are like 1A, 2A, there's 3A, 4A, 5A, 6A, and then 7A and 8A. And these are typically going to be seen in Roman numerals on your reference sheet. And then there's the drop down part, kind of the bridge that connects the two parts. Those are our group B elements. And then we have these two rows that are at the very, very bottom of the periodic table. So kind of looking at the names of the different areas that you should have recognized in the notes from yesterday. All of the group A elements, so those first two columns to the left, which are right here. Sorry, my pen stopped working. So these first two columns and the last six are all of the group A elements. Those are referred to as the representative elements. And that does include metals and non-metals. So there are representative metals and representative non-metals. That group 1A, the one furthest to the left, those we refer to as our alkali metals. So notice this one, there's alkali that ends in an I. There's no ending on it, and those are just metals. Whereas group 2A is alkaline earth metals. People tend to confuse these two or start mixing up the names. So make sure that you have group 1A is alkali metals and group 2A is alkaline earth metals. That group 7A, so on the right side of the periodic table, but not the very last row on the right, the one right before it, those we refer to as our halogens. So that has like fluorine, chlorine, bromine, some of those that are in it. And then that brings us to group 8A. This is the one on the far right. Those are what we refer to a lot of times as inert gases. They're gases that don't react with a lot of other substances. So we also refer to these as noble gases. So make sure that you are able to kind of find those specific groups on the periodic table. We also have those group B elements. These are the ones that are in the middle of the periodic table. So like I said, that kind of drop down that connects the two sides of the periodic table together. Those we refer to as our transition metals. And then I have this down below. It's not shown on the screen, but these two rows at the very bottom that are disconnected from the rest of the periodic table, these we refer to as our inner transition metals. You'll also hear these referred to as the lanthanide and actinide series because those are the elements at the very beginning of those two rows. The reason these are called the inner transition metals is these are actually a part of the 6th and 7th row of the periodic table. But to keep your periodic table from being multiple pages wide, for it to fit on one, they just kind of pulled those areas out of the main periodic table and put them at the bottom. These are all or mostly man-made substances, not all man-made. These are mostly radioactive. We tend to not deal with these a whole lot in nature or even in lab settings and things like that. They're just kind of too unpredictable. So hopefully between the guided notes and this review, you're able to recognize different parts of the periodic table and name them if needed. All right, so let's switch gears onto today's notes. So today we're going to talk a little bit more about matter. Looking at what is matter and the different types of matter. So after the notes today, you should be able to classify matter and split it up into some of the different groups that we have. So looking at what is matter, it is anything that has a mass and takes up space. So mass is the amount of matter an object contains. So it's anything that contains particles and takes up space. Even gases that are around us are made up of particles and take up space. So everything, every substance we know of is considered to be matter. So we first look at states of matter. So matter can exist in different phases for us. And these are things that you have probably heard before in previous science classes, but you should be able to kind of recognize them based off of their definitions. So we have three main states of matter that we deal with. The first one is a solid. This is matter that has a definite shape and a definite volume. So that means that the shape does not change and the volume does not change. So think of the desk you're sitting in. You're not going to be able to push down on your desk and compress those particles and make your desk smaller. It's going to stay that shape and that volume, take up that same amount of space. In a solid, the particles are closely packed together. There is not a lot of empty space between particles. So they do not compress or expand easily. If we're looking at like the particulate level, if we were zoomed in and able to see all the individual particles, you would see in a solid that all of the particles are touching and there's not gaps where it can be compressed. So whenever you're looking at a solid, you're going to see all of the particles packed together. In terms of a liquid, liquid is matter that has a definite volume. So the volume does not change, but it has an indefinite shape. So the shape can change, but the volume is constant. So with liquids, it partially takes the shape of its container and has the ability to flow. So what I mean by it partially takes the shape of its container, if you were to pour a 12-ounce can of soda into a 16-ounce glass, it is going to fill the glass up to 12 ounces. It's not going to expand to fill those other 4 ounces to fill the 16-ounce cup because we only had 12 ounces of soda. But maybe your cup is a different cylindrical shape than the can is. If you dump it over and it spills in the floor, it's now in the shape of a puddle, but the volume is still the same. And with these, where the particles have the ability to flow, so the particles in a liquid are still going to be touching, but a lot of times there tends to be more of a gap, and the particles are able to switch spots with one another, whereas in a solid, they cannot do that. In liquids, because there's still not a lot of empty space, the particles cannot be compressed. I worked as a waitress once upon a time whenever I was going through school. And if you have a cup that still has liquid in it and you put another cup inside that one, the water overflows because you cannot compress it and push it down anymore. However, liquid will expand when heated. So think if you've ever made like mac and cheese or something, if you fill the pot too much, that water expands when it heats and it will overflow the pot. That's why you have to leave space at the top of the pot for that water to expand. All right, so then our third state of matter is going to be a gas. Gas is matter that has an indefinite shape and an indefinite volume. So both the shape and volume can change. So with gases, it will take the shape of and volume of its container. So it will take the shape of the container, similar to the liquid, but the gas will completely fill the volume of the container, whereas the liquid couldn't change its volume. With gases, when you see a gas, there's going to be a lot of empty space between particles. So the gas can be compressed and you can push those particles together to fill that empty space. And gases also expand when heated. So that's why if you ever have like a balloon, if you get it too close to a heat source, it will pop because the gas expands and then the balloon can no longer hold in that gas anymore. Same thing if you've ever cooked and you have like Pam cooking spray or non-stick spray, it tells you to keep it away from heat because the gas inside can expand if it gets too hot and the can could possibly explode. You'll also hear us talk about vapors throughout the course of the semester. A vapor is a gas, but is the gas state of a substance that is normally liquid or solid at room temperature. So think of water at room temperature is a liquid. Whenever we boil water, we create water vapor. So it's the gas state of water since it's normally liquid at room temperature. All right, so let's look at our different types of matter that we come across. So we talked about states of matter, which you were probably familiar with. Types of matter you may not be familiar with. All matter is going to be split up into two main categories. We have mixtures and pure substances. So let's look at mixtures first. Most matter that we deal with are going to be considered mixtures. So mixture is a physical blend of two or more substances. So what it means by it's a physical blend, you just kind of dump everything in a bowl together and stir. So things are not attached to one another. They're not bonded together. They just happen to be taking up the same space. Mixtures vary in composition, so they can be different depending on who made that mixture or maybe the brand of that mixture. And these can be physically separated. So a lot of times, because they are not bonded together, we can just pull apart the pieces. Mixtures are further split into two different categories. We have heterogeneous mixtures and homogeneous mixtures. So the prefixes in those you should be familiar with from biology. So if you remember, hetero means different. So in heterogeneous mixtures, it's a mixture without a uniform composition. So that means you're going to be able to see all the different parts of it. So you might see it split into layers, or the particles might be large enough that you can see the individual particles. So you're able to pick out or see the different parts of a mixture. So think of if you have like a bowl of trail mix, you are able to see like the peanuts, the cashews, the almonds, maybe there's raisins in there, maybe there's M&Ms in there. You can see all the different parts of those. That's an example of a heterogeneous mixture. Or if we have like Italian salad dressing or something like that, that has a lot of oil in it. If you let it sit, it separates out into like the seasonings, the oil, and the water. It has all the different layers to it. Whereas a homogeneous mixture, remember, homo means same. So homogeneous mixtures have a uniform composition. That means that everything looks the same. Even though we know there's different things in there, we can't see all the individual parts of it. So the components are evenly distributed and cannot be distinguished from one another. So think of like soda. Soda has water, it has carbonation, it has flavoring, it has sugar. It might even have like coloring added, different things like that. When you pour the soda into a clear cup, you're not going to see all the individual ingredients. It looks all the same throughout. And the homogeneous mixtures we refer to as solutions in chemistry. So whenever we do lab and we have solutions, a lot of time we've taken that chemical and dissolved it in water. You cannot tell where the water is and where the chemical is. They mix together thoroughly, but it all looks like one substance. With mixtures, we said these can be physically separated. So looking at how these are actually separated. Some mixtures can be separated simply by picking apart the components. So going back to our trail mix, say that you don't like raisins, you can pick out the raisins and eat the rest. The particles are large enough for you to be able to separate them just by picking out pieces with your hand. Now, if we were dealing with soda, we can't like take out the coloring just by picking it up. We can't see the particles. We cannot separate them that easily. So the homogeneous mixtures can't be separated in that way. A lot of times they have to be filtered or distilled. When something is distilled, the liquid is boiled to produce a vapor, and then that vapor recondenses to form a liquid. So this is what they'll do in areas where the drinking water is not safe. A lot of times they actually have distillation machines where you put in the water, it gets boiled, the gas, the water vapor goes through a tube, and it will kind of condense on ice at the other end of the tube, leaving behind any toxins or things that might be in the water, and then it created pure water. If you have any type of like humidifier in your house or things like that, a lot of times those will use distilled water. It's just water that's been boiled to take out any like minerals and things like that. So it does separate the different components out. All right, so we said that all matter is either a mixture or pure substance. So pure substances have a definite and uniform composition. So that means we know exactly what they're made of, and they are always identical. So if they're uniform, they're identical. And pure substances are split up into two different subcategories. And what makes pure substances different from a mixture is that they have a uniform composition, but these cannot be separated physically. So we cannot just pull the pieces apart to separate them into the individual components. One type of pure substance we have is an element. Elements are the simplest form of matter that cannot be broken down into any other substance. So in an element, all of the particles are identical. They tend to be individual most of the time. There are cases where we might have two atoms of the same element attached. Like we breathe oxygen as O2 that has two oxygen particles that are connected. Elements are the building blocks of all other substances. So everything is going to be made up of elements. And there are 118 of them that we know of. So anything off your periodic table is an element. But like I said, do be conscious that some things like oxygen is O2. So there are two identical particles that are connected together. Where something like carbon or iron is just going to be a single particle, a single atom. Then we can actually have elements that combine to make compounds. So a compound is a substance that can be separated into smaller substances. So it can be separated out into the elements, but it has to be by chemical means. So with a compound, you have two different types of particles, two different types of atoms that are actually connected and bonded together. You cannot simply just pull them apart. Something has to be done to split that attachment or split that bond. The compounds you are going to have a formula for. So like salt is sodium chloride or NaCl. No matter if you buy name brand salt or like the Walmart brand salt, it is still NaCl. It's not different from one brand to the next. Same thing with sugar. Sugar is C6H12O6. It has carbon, hydrogen, and oxygen. No matter if you buy the Domino brand sugar or the Walmart brand sugar, they're identical. It's the same chemical makeup. And these have to be broken down by chemical means. They have to be like heated or burned, electricity run through them, something like that, that will actually sever and break apart that bond. So let's look at kind of summarizing our different types of matter. So everything is considered to be matter. And we said matter that can be separated physically, so that can be just pulled apart, are going to be mixtures. Matter that cannot be separated physically are going to be our pure substances. So looking at mixtures, we said there's two types of mixtures. There are mixtures that have a uniform composition where everything looks identical. Those are going to be the homogeneous mixtures. And then we have the mixtures that have a non-uniform composition. So you're going to be able to see different parts of the mixture. That's going to be our heterogeneous mixture. Looking at the pure substances, we have pure substances that cannot be broken down any further. So they're the smallest part that they can be. Those are elements. And then we have pure substances that can be broken down, but it has to be chemically. So remember, these are our compounds that can be broken down and split up into elements. So you guys are going to be doing an activity. It's a classification of matter card sort. You guys are going to be working in small groups for this, but you're going to have a selection of cards that have particle diagrams, similar to the ones that I drew for the states of matter. Based off of these particles, you're going to have to decide that individual card, is it representing a mixture where there are different types of particles there, but they are not attached to one another? Or is it a pure substance where the entire card has the same type of particle? Once you have those two groups established, and you'll notice that there are lines, there are the correct number of lines for how many of the cards are mixtures and how many of the cards are pure substances. It will then have you take those two groups and split them up further into elements and compounds. Or is it a mixture of elements, a mixture of compounds, or a mixture of an element and a compound combined? So refer back to the notes as needed for some of the definitions and talk about it with your group and really think about, what do you see on the card? Is everything the same, or do you see different things on the card? And that will help you sort them into groups. And we'll come back tomorrow to finish up for the unit.